For this next video, we'll take a look at the second page of your practice quiz. At the bottom of the first page, we had inventory of the atoms on either side, and they were the same types of atoms, but they weren't the same numbers of each type of atom. So because of that, we declare that this is an unbalanced chemical equation. And that is for the very reason that, let's see, here's the pen, yep. Unbalanced because the number, if I can zoom in on that a little bit, the number and, that's an and sign, types of atoms on each side of the equation, meaning the arrow, each side of the chemical equation are not equal. Are not equal. So again, we recognize that we have the same list of atoms. That's requirement number one, because we can't create new atoms during a chemical reaction, but the number of each type of those atoms is not the same, therefore it's unbalanced. Okay. So then we go through the balancing process, and so we look at this diagram, and we are going to inventory the atoms. So I think these were H, Br, and Mg. And we have the same list of atoms on each side. Okay, and so we have one of each. And if you forget which atom is which, you can look at page 1. Here we have 2 hydrogen, 1 bromine, 1 magnesium. I think that's the magnesium. I'm just going to make a note of that. Okay. So now we need to balance this. Well, we've got not enough hydrogen on the left-hand side because we're going to make an H2 molecule, and yet there's only 1 hydrogen atom represented here. So what that means is we need another one of these molecules. We can't just draw individual small circles because that's not one of the reactants. And so I'm going to draw another one of these molecules. In fact, I'm going to use the copy-paste feature. So I'm going to grab that molecule right there, and it's very kindly it's going to duplicate it. All right, so I add another one of those reactant molecules. That gets me the 2 hydrogen, so that's good. So I'm going to update my count. I now indeed have 2 hydrogen, but I also now have 2 bromine. And that's a little bit of a bummer because I only have 1 so far on my reactant side, but that's the game that we're playing, trying to balance it. And I still have the 1 magnesium. Okay, so looking at that, I need additional bromine. And so what I'm going to do is I can't just add the thickly outlined circle. I have to add it as part of this formula unit right here. So I'm going to do that. I'm going to do the copy paste. It's going to give me another one of those. Perfect. So now I do indeed have 2 of the bromine atoms, those thickly outlined circles, so I can update my count. All right, but I've also now got 2 magnesium, and so I'm going to update the count there. So my hydrogen, bromine, magnesium count is 221 on the left side of the equation and 222 on the right. So how am I going to solve that? Well, I'm going to come back and add a single atom of magnesium. And the reason I can do that in this case is because for metals, their representative particle is individual atoms, as represented here. So copy paste that one. Okay. So now I update my left side count. And now I have hydrogen, bromine, magnesium going 222 on the left and 222 on the right. So the last part of this is just to turn that into the formality of the balanced chemical equation. So with my pen in hand, this first part here, these were HBr units, HBr molecules, if you will. And again, we could flip back to the front page if we forgot what that title was. So I'm going to write HBr. But we drew 2 of them. And then we have magnesium atoms there, Mg. But we have 2 of them. That yields a single H2 molecule plus the magnesium bromide and we've got 2 of them. So that's our balanced chemical equation. Okay, well, I've come back to this video just to add a couple seconds. I noticed as I was doing this last bit here that while the conceptual teaching is good, I've actually got the wrong formula right from the first page for magnesium bromide. So that would throw off the actual diagrams themselves, but this was still a good practice of the process. So even though there was an error in the chemistry formula, it still served its purpose. Thank you.